In this video, I want to have a look at angles in parallel lines. So if we have two lines that don't necessarily have to be parallel, if we've got two lines and we have a third line that crosses over both of them, that third line is called a transversal. So for example, here we have these two blue lines. The red one crosses over those two, so the red line is called our transversal. So when we have two lines and a transversal, it forms 8 different angles. So we've got 1, 2, 3, 4, 5, 6, 7, 8 of them. Now we're going to have a look at the relationships between those 8 angles, but specifically we're going to have a look at when the two lines are parallel, because that will form special relationships. And there's 3 main relationships that we're going to have a look at. So the first type of angle relationship we're going to look at are what are called corresponding angles. So corresponding angles are equal, so they're exactly the same size. What they look like is, it looks like the angle has been slid up or down the transversal. So if we have a look, if we picked, for example, this angle here, so this one, if we slide that down along the transversal, this angle here would be corresponding to it. And that means that those two angles are exactly the same size. If instead, so we picked this one up here, again, if we slide that down along the transversal, this one here would be its corresponding angle. If we picked, for example, this angle here, then we could slide that up and we'd have this angle here, which would be exactly the same size because it's corresponding. And the last one, we could do this one here and slide it this direction to get this angle here. So they're all examples of corresponding angles. And these angles in each set, the pairs of corresponding angles, would be exactly equal in size. The second relationship we want to look at is what are called alternate angles. So alternate angles are equal in size as well, but they look a little bit different in our diagrams. So alternate angles are both inside our parallel lines on the opposite sides of the transversal. So for example, if I picked this angle here, the alternate angle, we're still going to stay inside inside the parallel line, so we're not going out into any of these, but it's going to be on the opposite side of the transversal, so it's going to flip out over here. So those two angles are alternate, which means they're exactly the same size. We could also have, for example, if we picked this one here, then this angle here would be its alternate angle. If we picked, for example, this angle here, then this one would be alternate. And our last one, if we picked, for example, this angle here would be that one would be alternate. It's also important that you can see that in each parallel line, there's 2 sets of alternate angles. So this one is also alternate to this one. These 2 angles here are alternate. These 2 are alternate, and these ones as well. So there's 2 sets every time you have a set of parallel lines and a transversal. Our last relationship are what we call cointerior angles. So cointerior, the word interior means inside, so that's going to help us interpret this in a minute. Cointerior angles are a little bit different to corresponding and alternate angles because they're not equal to each other. What they are is they're supplementary, which means that they add up to 180 degrees. When we're looking for them, the angles are both inside the parallel lines, just like the alternate angles were, but this time they're on the same side of the transversal. So for example, if we picked this angle here, the angle corresponding to that would be this one here. Now notice I've used different symbols to mark them because they're not the same size this time. So this angle plus this angle here would add up to 180 degrees. If we picked this angle here, the angle co-interior to that one would be this one up here. So same side of the transversal, still inside the parallel lines, and those 2 angles would add up to 180. Again, if I picked this one here would be its co-interior angle, and if I picked this one here, this one down the bottom here would be its co-interior angle. So when we're looking at parallel lines, anytime we have 2 parallel lines, those 3 relationships will always hold. So let's have a look at angles in parallel lines.